Let us look at this problem. A box of pencils is put on a conveyor belt that runs with a velocity of 0.059 miles per hour. If you set a box of marbles to run on the same conveyor belt, what is the velocity of the box of pencils relative to the box of marbles? In this problem, we are asked to calculate the relative velocity of the box of pencils, which we will assign as our object A. With respect to the velocity of the box of marbles, which is our vector B. Pause this video and try to solve it. In this problem, the conveyor belt is moving at a speed of 0.058 miles per hour. But even if it is moving at the same speed, the velocity of the box of pencil relative to its fixed place in the conveyor belt is still 0 mph. This principle is true for the box of marbles. Therefore, we have the given as V sub A is equal to 0 mph and V sub B is equal to 0 mile per hour. Here, it is clear that the velocity of the box of pencils relative to the velocity of the box of marbles is 0, which concludes that both of these boxes are moving neither away or toward each other. Let us have this example too. A yellow cab driving along the highway with a velocity of 29 miles per hour overtakes another car. From a passenger's perspective, the relative velocity of the second car relative to the yellow car is 4 miles per hour. Identify the second car's velocity. In this problem, you are asked to calculate for the velocity of the second car. I will pause this video and let us see your answer before we proceed with the computation. In this problem, the yellow cab is our object A, and it has a velocity of 29 miles per hour. The relative velocity of the second car with respect to our object is also given as 4 miles per hour. Before I continue, may I know the correct working equation to be used? That is correct. It must be V sub BA is equal to V sub A plus V sub B. Now that we identified the appropriate working equation, we will substitute the values as 4 miles per hour is equal to 29 miles per hour plus negative V sub B. In this case, you will notice that the second car assumes a negative velocity because as the yellow cab moves past it would appear to be moving backwards from the vantage of the car. At this point, we will substitute the values as V sub B is equal to 4 mph minus 29 mph, which is then equal to negative 25 mph. And that is the velocity of the second object. Let us have the last problem for this lecture. A motorboat heads north with a velocity of 5 meters per second on a river whose current is moving at a velocity of 2 meters per second to the east. What is the velocity of the motorboat relative to a person watching it from a riverbank in miles per hour? Again, try to solve this. Let us analyze this problem. We are asked to calculate the relative velocity, which we represent as V sub AB of the motorboat, which is our object A, affected by the current, which is our object B, with respect to the person watching it from the riverbank. A quick look at the direction would tell us that this is relative motion in two directions. Therefore, we will use the Pythagorean theorem to find for the relative velocity. Substituting the values and performing the operations, our final answer in meter per second is 5.39 meters per second. Now, the question asks us to solve this in miles per hour. So, let us have a dimensional analysis here. 5.39 meters per second multiplied by, let us focus first in converting meters to miles. So we will multiply this to conversion factor, 1 kilometer times 1,000 meters. We learned in our module 1 that the same unit must be found in both numerator and denominator, so we can cancel them, and only the unit in the numerator will be left. Therefore, we will cancel meters. Then, we will add another conversion unit as 0.621 miles over 1 kilometer. Now that what will be left is a unit miles, we are interested to have seconds converted to hour by multiplying this to 3,600 seconds over hour. You will notice in our dimensional analysis that when we cancel all the units, miles in the numerator and hour in the denominator will be left, which is the unit we would like to have. Perform this operation in your scientific calculator. You may type this as it looks like, and you will get 12.05 mph. Now that we have the magnitude already, we will now look for the angle. We can do shortcut as theta, which is our angle, is equal to arc tan times 5 meter per second, which is our opposite side, over 2 meters per second, which is our adjacent side. Here, we will get the answer of 68.2 degrees. You can as well do the long method and you will get the same answer.